All right, question number 21. Find the area. You know, that's a integration question. Step number 1 is I'm going to graph this. So what would this look like? 1/2 to the x. Well, if I plug in 0, I know the answer is 1. Because the base is a fraction, less than 1. This is a decreasing exponential. So I know the exponential curve, but it's decreasing. X equals -2. That's over here. X equals 0, that's the axis. And then y equals 0, that's the axis. So it's this area right in here. So I want to find to integrate. So I know I'm integrating from -2 to 0. I know it's top subtract bottom. So that's top subtract bottom. And then I need to integrate that. So the integration of an exponential, you copy it, and then you divide by ln of the base. And then I'm going to plug in 0. And then I'm going to plug in -2. Now -2 does the reciprocal. So the reciprocal of 1/2 is 2, and then square it, so that's where you get 4. It might seem like the answer is negative, but ln of 1/2 is a negative answer. So it's really a negative times a negative. Now this is also negative, but it's a smaller negative. If you put that in your calculator, it would be a positive answer. 22. Without using a calculator, find the volume of a solid formed by revolving the region bounded by y equals the square root of x over x squared plus 2, y equals 0, x equals 0, x equals 2. All right, let's graph this. You're like, I have no clue. Well, let's just start with the value. So plug 0 in. The answer is 0. Plug 2 in. It's 2 squared. That's 4 plus 2. That's 2 over 6, or 1/3. The square root of 1/3. What I do know is when I plug in 2, it's greater than 0. So the square root of 1/3, right? And then the idea is it concave up or concave down. It's a square root, right? An idea. So have that. Ultimately, this doesn't affect anything. I'm just trying to get an idea of top subtract bottom. So if I think of the volume, this is my base, and I'm revolving it about the x-axis, just one circle. So it's pi. Top subtract bottom is just the curve. I'm going to write it calculus friendly. And the bounds. And there you go. So pi r, oh, and I got to square it, sorry. So pi r squared, and then I put that in. I really didn't need calculus friendly, but what I want you to notice here is that the 1/2 and the 2 just leave you with x over x squared plus 2. Whenever I see a fraction, I cycle through different possibilities of how to integrate it. So the first one I think about is a logarithm. The derivative of the denominator is 2x. So it was a 1, and now it's a 2. So 1 over 2, that's what I need in front, so it stays the same. So the answer is going to start with pi over 2. Then it's the logarithm of the denominator, and I'm integrating from 0 to 2. Then the last step is I plug in 2, and I get ln 4. And then I plug in 0, and I get ln 2. There's the answer. Oh, wait a second. 2 squared plus 2 is 6. All right, number 23. Without using a calculator, find the volume of a solid formed by the square cross-sections perpendicular to the y-axis, whose base is the region bounded by x times y equals 4, x equals 0, y equals 1, and y equals 4. So because it's perpendicular to the y-axis, I'm going to write this as x equals 4 over y. So I divide it by y, so I have everything in terms of y. If I was going to graph this, I know at y equals 0, which is right here, there's a asymptote. And if I plug in 1, the answer is 4. So at 4, the answer is 1. And then if I plug in 4, 4 divided by 4 is 1. So at 1, the answer is 4. So I plug these values in. So when y is 1, x is 4, I plot it. When y is 4, x is 1, right? And I plot these 2 points, and then you can draw a curve of it. This is what the curve looks like. And it's from x equals 0, y equals 1, and y equals 4. So this is it right here. All right, we're going to probably use the shall method, maybe? No. Because it's easy to do in terms of y, I can just do it the easier way. So the bounds are the y's, goes 1 to 4. Right subtract left would be 4 over y, subtract 0. Remember, this is revolving, right? Oh, square cross sections. So these are going to be, so when I go right subtract left, that goes the base of my square. This is 16 over y squared. Make it calculus friendly. This is not logarithm because the derivative of the bottom doesn't match the top. But it's not too bad to integrate. So I'm going to add 1 and divide by that from 1 to 4. Then I'm going to plug in 4. And then I'm going to plug in 1. Just for fun, if you had to integrate this, if you had to simplify it for multiple choice, 4 to the negative 1 means 1/4. 1 to any exponent is 1, so this is just 16. Now the 2 negatives will make this positive. And then 16 times 1/4, or 1/4 of 16, divide by 4. So this is negative 4 plus 16, so the answer is 12, if you had to get to this point for multiple choice. 24. In number 24, you're given the graph of a region. This is sine squared, and the x-axis. Without using a calculator, find the volume of the solid formed when this region is revolved about the y-axis. So it's revolved about the y-axis. So first I need to know the bound here. So I need to go sine x squared. So I know this bound is 0, but I don't know this value. So I'm going to take the function and make it equal to 0. Now, in order to understand it, I need to know at what angle gives you the answer 0. So the angle that gives you the answer 0, if you think of the unit circle, 0 gives you the answer 0. The other one is pi over here. So on top, it's positive 1, negative 1, pi. So if I let x squared equal pi and square root it, then I get the square root of pi being the bound. So it goes from 0 to the square root of pi. I'm revolving it, and because I'm revolving this around the y, it's going to be like to solve for x, to change this equation around, we need to do this parallel. We have to do a shell method to make it easier. So the radius is going to be the x coordinate. And then top subtract bottom is just the curve subtract 0. So the height of it is just sine x squared. And then 2 pi. So the radius is just the x coordinate, and the height is sine x squared, take away 0, or just sine x squared. And then that's the formula to use. So the derivative of x squared is 2x. What it was over what it became is 1 over 2. So this just simplifies to pi. Now we can integrate this. So we can, oops, this is an x. I can unhook this, and then the derivative rule for sine is negative cosine. Oops, no dx anymore. And that's from 0 to root pi. And then you plug in. So plug in root pi. And plug in 0. Now, just for fun, the square root of pi squared is just pi. So the value of cosine at pi is negative 1. So we have a negative and a negative 1. The value of cosine at 0 is positive 1. Oh, this is subtracting and a negative. There you go. It was going to equal 0, and that didn't make sense. So subtract a negative. It's now adding, and a negative, so it ends up being just pi plus pi, which is 2 pi is the answer. Good question. 25. I know. I think it's a good question. Find the perimeter of the region R from question number 24. So perimeter is the arc length. So it goes from 0 to the square root of pi. 1 plus, you take the derivative and square it. So the derivative of sine x squared is cosine x squared 2x. So the derivative rule and the hook. And then put that in your calculator. Oh, and the perimeter of it, I also have to include. So we have the curve, but the perimeter also includes the bottom here. So from 0 to root pi, I got to include the bottom part too. So we do that. You're probably going to trust me, but if you put this in your calculator, the answer is 4.602 for the perimeter. So when you see perimeter, arc length, but then don't forget the line segments too to add it all up. Average value. Think about it. Press pause. Can you set it up? So this is an integration question. So I integrate the function and then I subtract the bounds. The integration of e to the negative t squared. Oh, just show an integral setup. Well, there it is right there. And then if you use your calculator, it'd be 0.746. So this says use a calculator. And then the answer is 0.746. Because I was thinking in terms of how to integrate it, and anyways, it wasn't coming to me. 27. We're almost there. You have 3x squared plus ln x. And it says 27, find the derivative, and then plug in 4. So that's 27. 28, it says integrate from 1 to 7. That's a calculator question. So type it in. We don't have an integration rule for ln, the logarithm. So this is a calculator question. Type it in. And the answer is 349.621. 3x squared plus ln x. This is also a calculator question. Can you type in solve, type it in, comma x, press pause, and try it, and see if you get the answer. All right, or it could be 8, 9 if you round it, but you can truncate. F is discontinuous when x equals 0, right? Because a logarithm must have a positive value. Is the discontinuity a whole, an asymptote, or a jump? And for 30, it's an asymptote. For a logarithm, right? Logarithms have asymptotes. 31. For a particle moving along, it has this velocity, e to the negative 1.3 t minus t ln 0.37 t. This is definitely a calculator question as I see the numbers. It says the time when the particle is at rest. So you take the velocity that you just see. So type this in, equal to 0, comma, t, solve it, press pause, and try it. So take this equation, equal to 0, and solve it with your calculator. .731. For B, the speed at t equals 4. So speed is the absolute value of velocity. So if you plug in, so at what number? At 4. So this is what we're doing. So we're going to plug in 4, and it's the absolute value of that answer. So plug in 4, and whatever answer you get, make it positive. Press pause and try it. 1.563. C. The acceleration is the derivative. And we want the derivative at 5. So, in your calculator, you're going to press menu, calculus, derivative at a point. And this is the value, 5. And you're going to type this in. Diamond enter. Try it. And control enter and see if you get the answer. Negative 1.617. D. The total distance traveled by the particle. Now, total distance is an integration question for velocity. So we're going to integrate from 1 to 5, and total distance is the absolute value of that. So you're going to type this in, you're going to find the absolute value bars, and then you're going to type this inside the absolute value bars, and then go enter, control enter. And the answer is 4.510, or 11, if you round it. Number 32. Press pause and do your best for number 32, then press play. Convert e to the 2x subtract 3 equals 7 to logarithmic form. So logarithm is another way to write an exponent. So the exponent, the logarithm base e, and then 7. And then to solve for x, we would add 3 and divide by 2. Use log properties. So this is just some pre-calculus work that's good to practice. Can you write this as one logarithm? And then solve for x. So this would be one logarithm would be a base of 2. This number is the exponent. So that's x cubed times x plus 1 divided by x squared I'm going to write this as an exponential. So what's inside the logarithm, I'm going to simplify this to just x times x plus 1, and then the base to the exponent 1. So this is x squared plus x, and then I'm going to subtract 2, and I'm going to solve it by factoring. I need to be careful here. So when I solve this, I have negative 2 and positive 1. But a logarithm cannot have a negative value in it, so the only answer that works is positive 1. All right, last question. Isn't that a beautiful sound? Last question. F and G are inverses. And so I'm going to do a chart to organize it. So F and G are inverses. A point on F, the graph of G passes through negative 1, 2. So, and 2, negative 1. That's G. So the inverse of that would be 2, negative 1, and negative 1, 2. The derivative for F at negative 1 is negative 2, and the derivative at 2 for F is negative 1. So these are inverses. And so the derivative at negative 1 would be the reciprocal, and the derivative at 2 would be the reciprocal, and the reciprocal of negative 1 is negative 1. And the question is find G prime at negative 1, find G prime at 2, and we just did it with the chart. I'm so proud of you. I know these assignments aren't always short, that you have work to do and you're working with me, and I'm really proud of you. Mr. G Math, over now. Till next time.